Okay, 2019 set, question 12. Let's move on. Sodium peroxide reacts with carbon dioxide. The partial pressure of carbon dioxide in a 0.5 dm cube sample of air is this right here, and the temperature is given. Calculate the moles of carbon dioxide present in air at this particular temperature. Again, for moles, we are going to use PV equals nRT, because look at the pressure, the temperature, everything is different, right? You can't effectively use V equals N times 24 or any of that stuff, because understand that that only works at RTP. The pressure is totally off compared to the room pressure, which is just 101 kPa. So pressure is given 5.37 and kilo, so 10 is power 3. Volume is given 0.5 dm cube converted into meter cube by timesing it by 10 is power minus 3. Moles we need to find. R is 8.31. Temperature is 273 plus 20, piece of cake. Please always write the proper expression for it. 5.37 into 10 is power 3 into 0.5 into 10 is power minus 3 divided by 8.31 times 293. Done. Now, what's the answer? Can somebody calculate that good stuff? Yeah, you get 1.103 into 10 is power minus 3. Okay, and since everything is correct to 3 sig fig, I write this correct to 3 sig fig as well, which is this right here, 1.10 into 10 is power minus 3 areno. Done. Now, calculate the mass of Na2O2 that would react fully with the amount of carbon dioxide calculated in part 1. So you have the moles of carbon dioxide is basically asking you to figure out the mass of Na2O2 using the equation. That's why the equation is given. 1 mole of carbon dioxide gives you 1 mole of Na, or reacts with 1 mole of Na2O2, right? So we have these many moles of carbon dioxide. The same moles of Na2O2 would be required. So what are the moles of Na2O2? It's the same. 1.10 into 10 is power minus 3. It's because it's 1:1. Done. And so what's the mass? Mass equal mole times molar mass. You have the moles, 1.10 into 10 is power minus 3. What's the molar mass of Na2O2? 23 times 2 plus 16 into 2. What do you get? Mass equal mole times molar mass. What do you get? So it's basically 1.1 into 10 is power minus 3 into 78. And so the final answer is 0.0860. Done. 3 sig fig, please. The preceding zeros don't count. 1, 2, 3, 3 sig fig. Okay, on to the next question. It's in chlorine exists as a diatomic gas, blah, blah, blah. He's giving you the pressure, the temperature, the volume. He's saying calculate the mass of chlorine. So first PV equals nRT. N will give you the moles, and then you could figure out the mass. Pretty simple, basic stuff, right? So what's the P? P is 404 into 10 is power 3, because it's kilopascals. So convert the kilo into 10 is power 3. Then its volume. Volume is 20 cm cube. 20 into 10 is power minus 6. Converted into meter cube. That's why. Moles we need to find. R is 8.31. Temperature is what? 273 plus 25, which equals to 298 Kelvin. So times it by 290. Please always write the expression. Please. 404 into 10 is power 3 into 20 into 10 is power minus 6 divided by 8.31 into 298. Always write the expression. So how many moles do you get? You get 3.26 into 10 is power minus 3. These are the moles of chlorine, and you need the mass. So mass equal mole times molar mass. Moles are 3.26 and molar mass, 3.26 into 10 is power minus 3, and molar mass is 71 for chlorine, because each Cl is 35.5. What do you get? 0.23 grams. 0.23. Done. Let me fix this. 0.23 grams. Done. Now I think calculate the number of chlorine atoms in the sample. You may find it helpful to use D part 1. If not, then you could use this value. See, there are 2-3 ways of going about this. First, you have the mass of chlorine. Convert the mass of chlorine into the moles of chlorine, and then from the moles of chlorine find the moles of the atoms, and then from the moles of the atoms find the number of the atoms. But I already have the moles of chlorine right here, which is 3.26 into 10 is power minus 3. So if you have 3.26 into 10 is power minus 3 moles of chlorine, what are the moles of Cl? Times this by 2, right? So what do? I times this by 2, fella. If I times this fella by 2, fella, if I times this by 2, what do I get? 6.525 into 10 is power minus 3. These are the moles of Cl atoms. And I don't need the moles of Cl atoms. I need what? The number. So times this by 6.02 into 10 is power 23. So they are effectively checking out how good you are in stoichiometry. What do you get? 3.91 into 10 is power 21. 3.91? Oh no, 3.93. Okay. Thank you. These are the number of atoms. Done. So it's piece of cake. Or what you could have done is you could have converted these grams into moles again. So you would have gotten this, and then once you got this moles, you would have done what? These would be the moles of chlorine. So the moles of chlorine times by 2, you'll get the moles of Cl atoms, the moles of atoms of chlorine, and then times this by Avogadro's constant. Remember the hidden relationship. Next, chlorine gas does not behave like an ideal gas under these conditions. Explain why chlorine gas behaves less ideally at very high pressures. Because again, there are two reasons. Main reasons, always remember the IMF and particle volume. So very high pressure particles, you want me to explain it? I'll explain it. Particles are closer together. Particles are closer together. And so what happens? The particle volume is no longer negligible. Versus what? Versus the volume of the container. Done. You could have also talked about IMF. Doesn't really make a difference. You could have even said that the IMF become significant at higher pressures because they're closer together, so IMF becomes significant. You could have also talked about this. Doesn't really matter. And at low temperatures, what happens? What happens at low temperatures? Particles are closer together. Particles are closer together, and thus what happens? And you could properly explain it. At low temperatures, the kinetic energy it results in lower kinetic energy, which means particles move slower and therefore are closer together. And so if they are closer together, the IMF is no longer insignificant, or the IMF becomes significant. No longer insignificant, or the IMF becomes significant. Whatever, however you want to write it. Or you could even say the collisions aren't elastic. Right? Is no longer insignificant, is no longer is no longer negligible, whatever. Right? We normally use the word negligible for particle volume and insignificant for temperatures. That's, if you want to keep it in mind, that's also an idea. Now, next question. Okay, he's saying interhalogen compounds such as blah 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 contain 2 or more different halogen atoms that are covalent. D is an interhalogen compound, which means there must be 2 or more halogen atoms, and it's saying it only contains chlorine and fluorine. Okay, good. Now he's given you the temperature, 0 degrees Celsius, the pressure, the volume, and the mass, and he's saying calculate the relative MR. Now you could do it directly, or you could first figure out the moles and then figure out the MR, or you could say, hey, PV equals nRT, and N. How do you calculate? How do you go from moles to MR? Mass equal mole times MR, or molar mass. And so you say, hey, moles equal mass divided by MR. Isn't that true? And so instead of N, you just plug in mass over MR. So PV equals mass RT divided by MR. What's P? It's 101,325. What's V? V is 1 dm cube, or 1 into 10 is power minus 3, because I need to convert it into meter cube. This is the entire thing about this particular chapter. You just need to know conversions. That's it. And so mass is 4.13, and the R is given 8.31, and T is what? T is 0 degrees Celsius, so it's 273 plus 0, it's 273. Always write the expression like I always say, right? Always write the expression. So, and this is MR के साथ multiply करना है, इसको MR right here. See, this MR is multiplied there. So MR times this equals this fellow. So make MR the subject. MR equals 4.13 into 8.31 into 273 divided by PV, 101,325 into 1.1 into 10 to the power minus 3. What do you get MR as? Calculate, please. $92.47. Thank you. But again, because all the data that's been given to me is 3 sig fig, you could even think of this. This shouldn't have been 6 sig fig, it should be in 3 sig fig. So the MR should also be in 3 sig fig, right? So 92.5. Done. That's the MR. Done. That's the MR. Now I think use your answer to part 1 to determine the molecular formula of D. If you are unable to calculate MR in 1, assume that the MR is 130.5. This is not the correct value. We know it's not correct, it's 2.5. But so if it contains only chlorine and fluorine, you just need to use your brain. CLF, this is 35.5 plus 19. No, this doesn't equal to 92. Cl2f अगर मैं करूँ तो this becomes 71 and this becomes 19, and so if I add this 71 plus 19, 80, 90, this is 90, so it can't be Cl2f and can't be Cl3f, so I'll have to stick with one Cl and then two Fs, so this is 19 times 2 and that's 35.5. That's not even yet. ClF3, if I do that, that would make sense. See, 35.5 plus 19 times 3. I think this is equal to, absolutely. This is equal to what? This is equal to 92.5 exactly. So the formula is ClF3. See, this is all trial and error. He's told you that it's only chlorine and fluorine. So you just do make some combinations out of it, because you just need to show that you don't exceed 92.5. If you do, see, I first looked into chlorine, I increased chlorine, but I realized that it doesn't fulfill it. I'm exceeding. If I go from Cl3, it already exceeds 92, so which means Cl must be 1, and then I played around with Fs, right? So that's just how you do it if you find it difficult. Done. Chalo, 2019 set over.